So let's start with the time up, which is 1.22 seconds, which is going to actually start with the velocity time graph. So where's your velocity time graph going to start?
12 meters per second.
12 meters per second. And then what's it going to do?
Go down.
Like this, right? Okay. So on this problem, we're not including the toss, okay? We're looking at this from the second that I let go of that ball until it lands, okay? I'm not including the throw. Technically, it starts at 0 and speeds up to 12. We're not worried about that part of it, okay? Now, as soon as you see the 12 meters per second, how do you know that the time up is going to be more than 1 second? Deacon.
You know that the initial velocity of the object is 12 meters per second, and the gravitational acceleration that gravity provides is negative 9.8 meters per second. So since the initial velocity is greater than the acceleration, then
It's a beautiful explanation, okay? Because again, what if the initial velocity had been exactly 9.8 meters per second? How long would it take to go to reach its maximum height?
exactly what
Exactly 1 second. So since that velocity is bigger than 9.8, you know your time up has to be more than 1 second, okay? So at this point, this right here is 1.22 seconds. Cool, right? Now, Jacob, you did this one, right? The max height?
Yeah.
Okay. Now, Jacob rolled the dice. How did Jacob roll the dice?
He relied on my time.
Yes. He used the time up. If that time up had been wrong, which in this case it wasn't, but if that time up had been wrong,
I would have screwed him over.
max height would have been wrong. Okay? So is there a way you could have found the max height without using time?
We use that equation.
Oh, you could use that equation. That's what, if it were me, that's what I would have done. Okay? I would have used that equation and gone d equals v squared minus v naught squared over 2a. Okay? That's what I would have done. Now, this is the level of work that I'm going to expect. So, Jacob did a nice job. He came in here and he put like that negative 9.8, and it's cool, right? So that's what I'm going to expect to see when you do this. So if you use that equation, I'd expect to see 0 squared minus 12 meters per second squared divided by 2 times negative 9.8 meters per second squared. Okay? I would expect to see that negative sign underneath there. Okay? Because if you just put 9.8, you're going to generate a negative distance. So you're going to tell me you're going to throw the ball up, but the maximum height is going to be below the ground. Okay? Cool. Probably not going to happen. Abby,
Do we need to include the 0?
you include what?
The 0 squared? Or can we just,
No, you just have to put the square. You don't have to put like meter squared over second squared, but just show me that quantity is squared. Okay? Does that answer the question?
not really, but.
Okay.
She was asking if she needs the 0 on the, to show the 0 on her work.
Well, technically, yes, because you just can't like randomly chuck a negative sign out there. Because it's 0 minus. That's what makes this top negative, and that's what dividing it by a negative number. Because if you just put this 12 squared divided by a negative number, mathematically, you're going to generate a negative displacement. Okay? All right. Now, time down. Cindy, you did this one?
Yes.
Okay. Now, she used the velocity at impact. Okay? And that's cool. Now, there's a couple of things that I would tweak. Time equals v minus a, that equation does not exist. That v over a is not an equation. What is an equation? V minus v naught. That's an equation. V over A is not an equation. I don't know which velocity you're using, okay? You're just thinking V over A, hoping a miracle happens. Now, if you're gonna do this, okay, and you can, on the way down, what's your initial velocity?
0.
0. What's your final velocity? Negative 17.3. That's what allows you to get that negative 17.3 minus 0 to get your time. Now, if it were me, and I were trying to find the time down, this is what I would do, just because I like this equation. If I were doing the time down, I would know that my maximum height is 15.35 meters. What I would do, I'd use 1/2 AT squared plus V naught time. On the way down, that's going to start at 0 because it's like I'm holding a ball up 15.35 meters, and I'm going to drop it, and I'm going to let it fall. Yes?
That's what I was like trying to say, like the little arrow thingy. Like if I do that, is it okay if I don't put the 0?
That's fine.
Okay.
Yes. Yes, that's cool. But you have to be careful here. So you solve that for time, you get 2 times 15.35 meters divided by negative 9.8 meters per second squared. Now, y'all have been my students long enough. Am I going to let that slide? No. Why?
You're not gonna get.
You're going to have a negative underneath the radical. So what should you do? Put negative 15.35 there. Okay? You're still going to get the 1.77 seconds. Okay? You're still going to get that exact same answer. It's just a personal preference on what you do. Okay? Now, velocity at impact. Faster you did this one, right?
Yep.
Now, here's the story. He set the initial velocity equal to 0. So what he's doing is that he's viewing this thing as falling, like 2 separate trips. Time up, and then the time down. So he's going to go ahead. Time down, boom, starts at 0. And he knows how far he's going to fall, or how long he's going to fall, 1.77 seconds. So if you're going to do this, you have to use the time down. Now, you initially used 1.22 seconds. What did you get?
Like
Negative 12, which is the opposite of the positive 12. So if you throw it up in the air, and it comes back down to the same height, it's going to leave at positive 12, but it's going to land at negative 12. Okay? Same magnitude of velocity, opposite directions. Okay? One's going to be positive, one's going to be negative. Same speed, opposite signs of velocity. But now, because it falls farther, right away you should be going, man, that should be going faster than 12, because it's going to fall all the way down to the ground. Okay? So that's one way you can do that. The other way that you can find the velocity at impact is you could use that equation. Okay? Initial velocity is 0, take the square root of that, 2 times negative 15.35 meters times. Now, you're going to get that exact same answer, but if you're going to use this, or that equation I should say, your calculator is going to give you the positive root. But what are you going to have to do? Make it negative, because it's going down at that point. So, this isn't bad. This is what I would do if it were me. Okay? You can do this. The advantage of that one is that it automatically generates a negative answer for your velocity. It makes me no difference, okay? Literally, that's what I'm telling you. There's probably 12 different permutations on how you can work this problem. But here's what I'm going to try and stress to you. You have to show me what you're doing, okay? The large portion of this grade on that particular problem is going to be the detail and quality of the work. If you put 9.8 times 1.77, and then miraculously you get a negative velocity, I'm gonna write on your paper, really? Miracle? Just magically turn negative, okay? I want to see those steps. Okay, so here's what I'm gonna give you. You're gonna get 2 pieces of paper, actually 3. So, before every test, at least kind of in the fall anyway, until you get used to my testing procedures, I'm gonna give you something like this. This is a blank set of problems, okay? You can do this, you can do the test. Like there's number 8 here, okay? Number 8 is identical to this. I changed the numbers, okay? You know that you're gonna have that type of problem on this test. Literally, the only thing I can change is the height of the building and the velocity of the ball. Okay, that's it. That's the only thing that I can change. I'm not gonna be a jerk and go, oh, tomorrow on the test, I'm gonna define down as being positive and up being negative. I wanna make the height of the building be the reference point. No! The ground's gonna be the reference point. Down is gonna be negative, up is gonna be positive. Okay? You know that problem's gonna be on there. You know it is. Here's one just like it. So not only are you gonna get this, then you're gonna get this sheet of paper, which has all of the problems worked out. So you're gonna know if you're doing them right. Now, don't do this. Let's say you read question number 1 on here and you're going, okay, da 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 da, gee, I know what to do. And then you look at my paper and you go, yeah, okay, that's exactly how I would have worked it the same way Burkamp did. Okay? No. Hide this. Do not even breathe on it. Okay? Work this. Use this as like an answer key to see how you did. If you run out of time, if you do nothing else, you work 8 and you work 9. If nothing else, you work 8 and 9. If nothing else. This is not due. I'm giving you the answer key. Okay? If you want to do it, great. It's up to you. Recommend.
So be at your risk.
This is a list of topics you're going to need to know for the test. Okay? That's all this is. Hey, what do you need to know about position time graphs, velocity time graphs, that type of thing. Okay? All right, Andrew, stop you on the camera.